So I'm comparing, this is our pattern P, this is our text T and this is our pattern. Not is our pattern. So I'm comparing what? The pattern character P of j, which is n, with this I plus j. I plus j is right now 0 plus 0. Right? Then what I'm doing, I'm fixing my I here, because when I compare the block, I shouldn't move my I index, because I represents the number of blocks. Right? So I'm still in my first block. So the index I represents the number of blocks. Remember that. So index I represents the number of blocks. Okay. So I'm still at I equals 0, but I want to move through this using my j. So I'm going to now say this is j equals 0. I'm comparing these two. This is what? J equals 1. I'm comparing I plus j. So that will be index 1, right? Because 0 plus 1, that is this index. Then I'm moving my j to this index, j equals 2, comparing 0 plus 2, I plus j is this index. So that's what I'm doing here. I plus j basically moves within this block using the j index. Okay? My I is still fixed here for that block. So after your j reaches the maximum, right? Because j cannot go beyond 2. That's why I'm checking here, j less than m. So within the loop, all you're doing is moving your j index, because as I said, if there's a match, you need to compare the subsequent characters, right? So that's what we are doing within the loop. We are moving the j index, j equals j plus 1, until you hit j less than m, because if j is equal to m, if j becomes 3, your m is our 3 characters, right? So if j equals 3, you have to come out of the while loop, because you don't have anything else to compare, right? So this while loop runs for a particular block. Okay? And then when you come out of the loop, what do you check? If you have matched all the characters. If your j reaches m, means you compare n with n matches, so you move your j from 0 to 1. So you compare O with O matches. Then you compare, then you increment your j becomes 2, right? You do what? T with b. When you compare t with b, j is still 2 less than 3, right? So it's true. And you're comparing what? T is the pattern character and the text has b in it. Are t and b the same? No. So what do you do? This condition becomes false. So you know how Boolean logic works, right? So true and false is false. So you come out of the while loop and you come to this if statement. In the if statement you have if j equals m. Your j is still 2, right? Because we did not go inside and increment the j, because the condition failed here, right? So j is 2 and you're checking j equals m. 2 equals 3? No, right? So the only time j will be equal to m when you come out of the loop is when? When this holds good and this also holds good, and you go inside and increment j equals j plus 1, which means if this was the t here, when j equals 2, 2 less than 3, and this t equals t. So if t equals t here, then what you do? You go inside the loop and increment your j from 2 to 3. And then you go back to the beginning of the loop, you check now what? 3 less than 3. Is 3 less than 3? No. So, you know also from what your programming classes, if the first condition is false in a while loop and in any loop, any Boolean statement, right? This is a kind of Boolean statement. You have an AND operation. So if the first part of the condition becomes false, the next part of the condition won't even be executed. Why? Because here we have AND. False and anything is false. Doesn't matter if it is true or false. Right? So, assuming that, since 3 is less than 3, or in general if j becomes equal to m, right? 3 is not less than 3, so j is kind of becomes equal to m, you have to come out of the while loop. So when you come out of the while loop, j is 3, right? That's why you came out of the while loop. J is no longer less than m. So j is equal to m, then you return what? The index I. The index I basically means starting from what index the pattern matches. So here starting from index 0, the knot here matches with the knot. So you identify the block ID, like later in the string if it matches there, what is the first character where there's a match and what's the corresponding index. That's what the I represents, the block number. Okay? So the summation clearly explains this. You go from I equals 0 to n minus m, and then, so if you write it as a double summation, the first summation is I equals 0 to n minus m. What is the inner loop? Inner loop goes from what? J equals 0 to all the way to, you go up to what? 2. So you do 0 to 2 in general, it is m minus 1. Right? Because m is 3 characters. Right? This is the case. So you go from 0, 1 and 2. Right? So until j equals m minus 1, because if j equals m, remember we are not doing this comparison. So this is our basic operation, the comparison. Comparing the character in the pattern, the character in the text. So we want to basically evaluate how many times we are doing this basic operation, this comparison, this equal to operation. So we are doing this only if this is true, j is less than m, right? So we are going through this, j equals 0, j equals 1, j equals 2. So 3 times. And how many times for a particular value of j? So for a fixed I, for a particular value of j, you are doing it once, right? So that's why we have 1. And that's what we solve all the way here, because if you solve it now formally, what will we get? The inner summation is, can anyone solve this now using the formulas? M. The inner summation is, how do you get m?
M minus 1 minus 0 plus 1.
Good. M minus 1 is the upper limit, minus 0 plus 1. So that is m. Right? And did we say m is the worst case number of comparisons? That's what this m indicates. So for every execution of this while loop, we will do at the worst case m comparisons. Okay? For a particular block, because I represents your block. So now m is a constant as far as this loop is concerned, because this is like what? For the I index. So here the only variable is n. Okay, so I can actually take this m outside and say this is m equals m times I equals 0 to n minus m 1. And this is nothing but this n minus m minus 0 plus 1. So it's n minus m plus 1. And you have this. Okay? Any question? So you should be able to analyze the algorithm and write its complexity. Now remember, you might have memorized some pseudocode before in your other courses. I heard that in some previous classes. Right? You don't need to memorize for this class any pseudocode. As long as you can analyze the algorithm, that's fine. Like in the exam quiz today, I gave you the pseudocode, right? And asked you to analyze. So that's how we expect the exam's questions to be. Okay? So I won't require you to memorize this. We don't need to do that. I'll give you this if in case I want you to analyze the algorithm like what how we did now. Okay? So, but when you have problems like we're going to do now, we have to know how to solve the problem. I won't use the pseudocode all the time. Only if I want to analyze the time complexity like what we did just now in the summation and all the stuff, then I'll give you like this. But if I want to solve some problems where you apply this algorithm, like we're going to just do now, you need to know what is going on and apply the algorithm. So I won't use a pseudocode for problems like this. Okay? Yeah? Okay, so this is quite easy. So we have, say, 1,000 zeros, and I want to search for these different patterns. The first pattern is 4 zeros followed by a 1. So what we want to find again is how many comparisons you will do at the worst case to find the presence of this pattern in this string. Right? We have 1,000 zeros and you want to search for this. comparisons you will be doing. Alright? So, let's go back to our fundamentals. This is almost like a formula now, the number of comparisons, right? The worst case number of comparisons is m times n minus n plus 1. N is known, n is 1000 zeros, m is 5, but you have to be careful here. Remember this n as the worst case, right? It depends how many comparisons. See, remember this inner block, right? It depends how many times we do the comparisons per block. Because, like in this case, you see here, you will compare the 0, 0, 0, 0 with the 1. In this particular example, you have to do all the way to the end, right? Like in the other second case, if it was like 1, 0, 0, 0, 0, you don't need to go beyond the first comparison for every block, because the 1 doesn't match with the 0, right? So per block, how many comparisons you are doing in this case? If you have 1, 0, 0, 0, 1 comparison. So this has to be then really 1 for your answer, right? 1 times number of blocks, right? So let me give you, this is the worst case, right? So in general, you can take this as a formula if you want. In general, what you do, the number of comparisons is the number of comparisons per block, multiplied by what? Number of blocks, right? The number of blocks is typically fixed. It is n times m plus 1, sorry, n minus m plus 1. So what is varying is the number of comparisons per block. This is actually a generic formula. Why? It fits for everything. If the best case scenario happens, best case means what? The worst case scenario happens. Best case means the first 3 characters match, but here we don't have like that, right? So we have to search for the entire thing. So the worst case, we have to compare all the characters within a block, right? So that is the length of the search pattern, which is 5 bits here. Alright? But if the first bit itself doesn't match like this, you need to do only 1 comparison. Or if you have something like this, 0, 1, 0, 0, 0, how many comparisons you do per block? 2. Because the 0 matches with the 0, but the second bit doesn't match. 1 doesn't match with the 0. Right? So you do 2 comparisons here. So let's do 1 by 1, so that we'll put everything together. So let's start with this. You have 0, 5, 4 zeros followed by a 1. So how many comparisons you do per block?
Per block, 5.
For 5. And then it's all zeros, so same thing, right? So you will move around block by block. So we will do, for the first case, as I said here, you do 5 comparisons. So 5 times, how many blocks are there? 1000 is the length of the string, minus 5 is the length of the pattern. So 1000 minus 5 plus 1. So that is 996 times 5, right? 996 times 5 is 4980. Okay? Then let's do the second one. You have 1, 0, 0, 0, 0. So here how many comparisons per block? 1. So it is 1 times again 996, because that's not going to change the number of blocks. So that is 1 times 996, which is 996. What about this? 2 comparisons per block, so it's 2 times 996. That's going to be 1992. Okay? Quite simple. Right? So this is a brute force approach. If you look in Google and browse for more efficient string matching algorithm, so this falls in the category of what's called string matching, which means you're trying to search for a particular pattern within a string. Okay, so this is a brute force approach, just going around here, as we said, search through the string, right? And that's of complexity n, set of n, Okay, where n is the length of the search the string, the whole string, and m is the length of the pattern. efficient algorithms, right? And that's actually the scope of this course. So we'll start with some inefficient approaches like brute force, and then slowly look at more efficient algorithm strategies. Okay? Is that clear? But for some problems, depends on the problem, what strategy you could use. For some problem, brute force itself may be the only approach. You may not be able to apply any other strategy like divide and conquer and all these things. For example, I doubt if you can apply divide and conquer here, it would be good. So that's why you can search in the internet if you see some people have proposed a divide and conquer approach. That's good actually. Divide and conquer is actually more efficient than brute force in general. Okay? So that's where research also is. So if you want to go for graduate school and do more research in this area, you could try to come up with more efficient algorithms. Okay? So let's do one more similar problem in this, string matching, and then move on. I'll post the question bank for this module soon also. Okay, so these questions will be there in the question bank. So let's do it as an example, and then you can even generalize this as an algorithm. This is a string given to you. You want to find the number of substrings. Basically, substrings means what? Part of a string, right? Small portion of a string. The number of substrings that begin with character A and end with character B. You see what I mean? So given a string like this, that has of course should have some A and B and all those things and some other characters like this. So you want to find the number of substrings that begin with A and end with B. Right? So there are two ways you can do brute force. One, brute force is too time consuming. What you will do? You'll start with this A and go over, or basically start with this string. This is not A, right? So then go to the next character, this is A. And find what?
B.
The B. And then, so that's one AB, right? AAXB, that's one substring, right? And what will you do? Here is where you have to be smart. If you are not efficient, what you will end up doing? You will fix you here and then move further here and say this is B. Right? For this A. Right? For this A, that's the next substring. So A, X, B, A, B. Remember, the B, A and B can be in between. So you want to find the number of substrings starting with an A and ending with a B. So there can be A, B in between also. Okay? And then you may move all the way here. And that's your next big string. And then what you will do, you could come back to this, move to this A and repeat this process. This is one string, and then this is the next string, this B, and then this B. Right? And then move to the next A and do like that. Right? That's one brute force. Isn't it? But how many times you went back and forth on the given string? Basically, can you analyze it? Huh?
Go back and forth, right?
Yeah, because remember what I did, I fixed my A here, and then I went to the entire string to find what starts with this A and counted the number of strings that end with the B, right? Then I came back. So I went over the string once, and I came back. And then I started with this A, and then went over the whole string once. Right? Or the rest of the string. Right? So, and then I came back, moved to the next one, and went over again. You see what I'm doing? So I am fixing at one end, then going to the rest of the string, and then moving there by one more index, and then moving the remaining string, and so on. Right? So if your string is of n characters long, how many times you are moving back and forth, the comparisons? You are doing basically n times. Let's do it like this. For the outer index I equals 0 to n minus 1, right? The index. You're going from index 0 all the way to n minus 1. The inner loop, the moving again inside, goes from j equals I to n minus 1. Because I I plus 1 because you don't need to compare A with A itself. So you compare the next character. So the inner one goes from compare the next character. So if you start with this A, see that this is a B. And then see this is a B and so on. So J equals I plus 1 to n minus 1. And you're doing it once. So this is a double summation. Right? Double summation, if you solve it, can you solve this? You should be able to solve by now, right? If you solve this, what answer you expect to get? Theta of what? N square. Good. The double summation with n always ends up with n square. Triple summation ends up with n cube. So you can solve it as a practice, okay? But you'll end up with theta of n square. So that's one way of doing brute force, but that's inefficient. Right? Can we do it efficient? Is there any other brute force approach we can do? Okay? That's what I've written here. We have a theta of n algorithm. We need to go to this string only once. We don't need to go through it n square times like we did here, back and forth. So just go through it once, and we'll be able to count the number of substrings starting with A and ending with B. Okay? So a little bit more intuition or kind of little bit more kind of some problem solving skill. That's how you see, you get the idea of how to attack problems. Right? So what you are going to do is you are going to do some bookkeeping. Bookkeeping means what? We are going to keep track of the number of A's we have seen so far as we scan through this string from index 0 to n minus 1 from left to right. As we scan through the string, we are going to keep track of the number of A's we have seen. And then based on that, we are going to keep track of the number of desired substrings that we have seen. Right? So in the previous case, we just kept track of the number of substrings that we have seen. We didn't keep track of the number of A's that we have seen. Right? Alright, so strategy is this. As we go through left to right, we are going to increment the number of A's we have seen. Right? Simultaneously, we are going to increment the number of substrings we have seen. When we are going to increment the number of substrings? Whenever we encounter a B. Good, because we want a string to substring start with A and end with a B. But rather than just counting the number of B's, what we are going to do is, we are going to add the number of substrings that we have seen to the latest value basically is the number of substrings we have seen so far until now or so far plus the number of A's. Okay, so this is your logic. Let's walk over the steps. To start with is a D, the first character. So the number of A's we have seen is 0. So you don't encounter a B, so this is also 0. And you initialize also then to 0. So they are already 0 to start with, and for D there is a 0. So now you have A here, so increment the number of A's to 1. But there's not a B here, so the number of substring is still 0. Okay? Then you have another A, you increment your number of A's from 1 to 2. You're seeing second A. It's not a B, so the number of substrings is still 0. Then you encounter an X, which is neither A nor B, so the number of A is still 2 and the number of substrings is 0. Then you encounter a B. It's not an A, so the number of A's is still 2, but the number of substrings is what? Whatever is so far, which is 0, plus the number of A's we have encountered so far, which is 2. So 0 plus 2 is 2. So what does it mean? When you encounter this B, whatever the A's we have seen so far can be part of the substring, which means AXB can be one substring and AXB can be the other substring. So we keep track of the number of A's we have seen so far, and we hit a B, whatever the number of A's we have seen can be part of the substring with this B. Right? That's the idea. Okay? The previous approach, we keep track of the A and then move down for the B. Whereas we are not going to do that here. We are keeping just track of the number of A's, and whenever we hit the B, All the A's before that can be part of the each of them can be part of the substring with this B. Alright? So let's move on. So this is an A. So the number of A is incremented from 2 to 3, and this is not a B, right? So it's A. So this thing remains the same. Then there's a B here. So the number of A is still 3, but number of desired substring is number of desired substrings met so far, which is 2, plus the number of A's, which is 3. So the number of substrings is 5. So what does it mean? Whatever the number of substrings we have formed with the previous B's, that's this 2, then the total number of A's, because this B that we met here can be combined with each of those A's that we have seen before, which A, this A, this A, and this A, so 3 A's. So the previous B's have already formed some substrings. That's kept track of this value, right? And this particular B can be combined with each of those A's that we have seen so far. Is that clear? So this particular B can be combined with this A, and then this B with this A, and then B with A. So all those things, A, X, B, A, B, A, X, B, A, B, then A, B. A, B is also a valid substring. So all those things can be considered substrings now. Right? So now keep moving. This is an A, so increment the number of A's to 4, and the substrings is still 5. Okay? Now we have a G, so it's neither A nor B, so it is still 4, 5. Now we have another B here. So what will you do?
Increase the A.
A is still the same, right? Because it's B, right? So the number of A is the same, but the number of substrings is the previous two things. The number of A's we have seen so far plus the number of substrings we have seen so far. So with all the previous B's and A's we have found 5 substrings. And then with this B, we can group that with each of those A's that we have seen before. So how many A's we have seen before? 4 A's. So that's why it's 4 plus 5, 9 strings. Okay? And then there's a B, so it's neither A nor a B. So how many times we went through the array? Just once. Right? So let's take off N. Stop this. It's done.